Poodle, what is this?
Bridge for cars to drive on.
It's a bridge for cars to drive over.
Mm.
Isn't it actually an Ethernet bridge?
Yes.
Ethernet bridge, well done. What is this?
A hub.
A hub? What is this then, Poodle?
A switch.
This is a hub.
Hub. Oh, sorry.
It looks like a switch, doesn't it?
These two hubs are for a pub.
They're hubs for a pub. Oh, I like that. What is this?
A router.
A router. What is this one? This is a funny one.
Repeater.
A repeater. It repeats signals.
It repeats stories.
It repeats stories. What is this one? You know what this one is.
A switch. It will turn the light in the roof.
It's a switch that turns on the light in the roof. Well done. And what about this one?
This one's also a switch. A better switch.
It's a better switch. Here we have a whole bunch of networking devices. And in this video, we're going to learn about network devices. Oh, you've got a book. Kali Linux Hacking. You love to hack.
Mm-hmm.
Well done, Poodle. Thing to remember is basic definition, routing, switching, dumb device. So no intelligence here. Intelligence based on MAC addresses. Intelligence based on IP addresses. I'll go through this in more detail later. Let's just look briefly at some of the devices that we had in the past and then some modern devices. The original Ethernet was 10^5 using this really big yellow cable. So this cable was restricted in distance. The signal would attenuate from one end of the cable to the other. And what they developed were repeaters. This is an example of a very early repeater. This would repeat the signal from one port to another. We could use 10^5 here or 10^2. So this amplified the signal basically. It didn't understand the actual signal, but it just amplified the signal from one port to another. Now you'll notice it doesn't have many ports on it. We've only got 2 ports. So it was simply repeating from one port to another. So example of a repeater. They then developed what was called a multi-port repeater. This is a Cisco Fast Hub 400 series. So we've got RJ45 connectors on the front. We've got power on the back. But the idea is a hub is essentially a multi-port repeater. We've got multiple ports and we are simply repeating the signal. We would connect RJ45, unshielded twisted pair as an example, to these ports. And what a hub does is, once again, it simply repeats the signal without understanding what's going on. So it doesn't understand the frames that it receives or the information that it receives. It simply amplifies it. So a repeater here would amplify the signal, amplify it from one port to another. Here we've got a multi-port repeater. It's repeating the signal from one port to multiple other ports. So if traffic was received on port 1 on this hub, it would simply amplify the signal out of all of those ports. So it repeats the signal out of every other port without understanding any of the details. Here's an example of a Netgear hub. On the front, we have 24 RJ45 ports, and on the back, we've got 10^2 as well as 10^5. So again, this would allow me to connect different cable types. So on the back, we could connect 10^5 as an example, and then on the front, we could have UTP, RJ45 cabling as we know today. This has no intelligence. There's no intelligence in the hub. There's no intelligence in the repeater. Remember, this is just repeating the signal from one port to another. This is a multi-port repeater. If something is received on this port, it just amplifies it out of all the other ports or repeats it out of all the other ports. Otherwise, we get attenuation of signals, and the signals degrade over a period of time, which restricts the length of a cable. This allows me to increase the length of the cable. Now, the problem in those days is the more devices that you have on the network, the more collisions that you're going to have, which causes problems and slows the network down. I'll talk more about that later, but the idea is this is a hub, this is a repeater. We don't worry too much about these days. A lot of people say, David, don't even show me hubs because they're pointless, but they forget that wireless, this is an example of a wireless access point, very modern wireless access point, supports Wi-Fi 6, the latest version of Wi-Fi at the time of this recording. A Wi-Fi network or a wireless network is essentially a hub in the air. We are sharing the air. So whatever I'm saying can be heard by you if you're within range. Both of us can't speak at the same time because it's a shared medium. We are sharing the air. Now, Wi-Fi 6 does try and implement some very clever stuff to allow multiple devices to talk at the same time. So it kind of approaches a switch, but it's still acting as a hub. So what is a switch? Here's an example of a switch. This is an older switch, 3750, very popular for doing labs, Cisco labs. Notice lots of ports on the switch. We've got 48 ports on the switch. The number of ports on your switch varies. You can have very small switches, you could have larger switches. Here's an example, is a 5-port switch, TP-Link switch, very small switch. Here's another 4-port switch from TP-Link. So you don't necessarily have lots of ports, but in an enterprise environment, you typically will. You'll have a lot of ports on a switch. These are smaller switches. The point is that the form factor, or the way that these devices look, varies. But the big difference between a switch and a hub is a switch has intelligence. A switch actually reads what are called the frames received on Ethernet. When you send data onto Ethernet, we are sending what's called a frame. So this device uses what's called a MAC address table. It's the same as these devices at the top here. They basically receive frames and they have the intelligence to only forward the frames out of the correct ports. So if there was a device with a certain MAC address on this port and traffic was received on this port, going to that MAC address, it would only be sent out of that port rather than out of all ports. A hub or multi-port repeater is dumb. When traffic is received on one port, it just simply amplifies it, or floods it is the term, out of all ports. So everyone receives that frame. Here, a switch has a MAC address table. It has some intelligence, and it learns where MAC addresses are in the network, and then it'll only forward the traffic out of the relevant ports based on the destination MAC address in a frame. So if traffic comes in this port, it's going to you based on your MAC address. It's learned that you're connected to this port. When traffic arrives on this port going to your MAC address, it's only going to be sent out of this port, whereas if it arrived on a hub, it would send it out of all ports. So big difference between a switch and a hub is a switch has intelligence. It works at what's called layer 2. We'll talk about that later in a moment. So it has some intelligence and it'll only forward the frames out of the correct ports. Now, some people would say, but hold on a minute, David, what is a bridge? A bridge you can think of as an intermediate device between a switch and a hub. So we had repeaters first, then we got hubs, and then we had bridges, which basically did things in software. They learned where the MAC addresses were of devices in the network, and then someone rebranded their devices as switches because they could learn MAC addresses in hardware. So they use something called an application-specific integrated circuit, or ASIC. So the lines are a little bit blurred, but for the CCNA, you don't have to worry about that. A switch learns where devices are, it learns where their MAC addresses are, and then will only forward the traffic out of the relevant ports. A bridge was an intermediate device between a switch and a hub. So historically, we had repeaters, then we had hubs, then we had bridges, software, switches if you like, and then we have switches today. Now notice the number of ports on the switch. There are many, many ports on the switch. So that's one of the features of switches. They allow us to connect many devices in our local area network. They essentially used for sending traffic within a local area network, or LAN. We're not going to try and send it from one network to another. These operate on MAC addresses using what's called layer 2 in the OSI model or TCP/IP model. Hubs are layer 1 devices. They are basically dumb devices. They don't understand what they receive. These are called layer 2 devices because they use Ethernet frames. And then we have routers which use IP addresses to route from one network to another. They are called layer 3 devices. We'll talk about those terms in a separate video. Layer 1, layer 2, layer 3, layer 4, and layer 5 to 7. You need to know those layers. You need to know the TCP/IP and OSI models. So don't worry too much about that for the moment. Just get an understanding. Dumb device repeats everything that it receives on one port out of all other ports. More intelligent device uses MAC addresses, learns where devices are, and then we have routers. Now your home device might look something like this TP-Link. This is a little TP-Link router. It allows us to route from one network to another. Typically, little routers like this allow us to go from our Ethernet LAN, local area network, onto the internet, so to what's called a WAN, wide area network. So Ethernet ports, this is how we connect our devices to the router. Wireless, and then we've got a connection to the internet. Here's a Cisco router. What you'll notice is this router is as big as the switch, but it has far fewer ports on it. We've only got a few Ethernet ports, and then we've got other types of ports. These are what are called serial ports. Now, fortunately, in the new CCNA, you don't have to learn about these serial interfaces. They were very slow, older interfaces. The most common WAN technology and LAN technology today is Ethernet. So Ethernet is what you need to know. So that's why I'm spending so much time discussing Ethernet. These older interfaces aren't that important today, but think of your home router. How do you connect to the internet? Maybe you've got an ADSL connection. So your service provider, mine here in the UK is British Telecom, they've given me an ADSL connection. Now, some of you may be fortunate enough to have fiber to your home. So in actual fact, your WAN connection is Ethernet in that case. But in the old days, it might have been something like this serial interface. But notice this router here. This is an interesting router, 1800 series router. This is an older router that would be used in a small, medium business or in a remote branch office of a large corporate. This device does a lot of things. It has old telephone connections here where you could put old analog phones in. So these ports here, these FXS ports, would allow you to connect an old analog phone to the router. And then this would allow you to make telephone calls to your service provider like AT&T or British Telecom, etc. It's also got a WAN interface, so one of these interfaces could go here. It also allows us to connect to the internet. It's also got like a switch part to it. So the idea here is this is kind of like a hybrid device. Routers today mix a lot of switching with them. Like I said, nothing is as simple as it seems. In its purest form, a router will route from one network to another. So as an example, we are routing from Ethernet to serial, or we are routing from physical Ethernet to wireless, or we are routing from one connection type to another. So as an example, this router could support voice over IP. We could have IP phones talking to analog phones. But this is where it gets a little bit less clear cut. This is what you need to remember. A router has routing functionality. In its most basic form, a router routes from one IP network to another. So here we're talking about IP addresses, such as IP version 4 or IP version 6 addresses. We are routing from one network to another, as in one IP network to another. In a lot of cases, we would be routing from one physical media to a different physical media. This is typically used for connections to the internet or to wide area networks. So we're connecting from a local area network to a wide area network. Switches are typically used in the local area network, so local within the building as an example, local at your home. You're not going to use this to route to the internet or route to other sites. A router does that function, so it routes from one network to another. Layer 2 switch, as this is called, uses MAC addresses, but switches today have routing functionality. So a switch like this is called a layer 3 switch because it has routing capabilities built into it. And then it will route from one VLAN or virtual local area network to another virtual local area network, basically from one subnet to another subnet. We'll talk about that later. Thing to remember is basic definition, routing, switching, dumb device. So no intelligence here. Intelligence based on MAC addresses, intelligence based on IP addresses.